Hello and welcome you all. So today we are going to look after an experiment. So here we have the mechatronic board here. This is the sensor board and this is the add-on board as told in the previous class, that is introduction class. So this is the add-on board, the white colored board, and over that we have placed the sensor board. So this is the mechatronic sensor board, and in this board we have around 10 to 11 number of sensors. You can see this is the encoder one, this is the reflective optical, this is the magnetic field, this is the pressure one, this is the potential rotary potential sensor we have, this is the infrared, the sonar, the thermistor, the strain gauge, the piezoelectric. So we have n number of softwares in this board, and it is connected to the Elvis add-on board. So in this experiment, for the today's experiment, we are only going to look after a particular sensor, that is rotary potential sensor. So unlike a potentiometer what you have used in your class 12 and all, so it is, the thing is almost same, works on the principle of voltage generation, the EMF generation once we move a particular thing. In your class 12 or class 11 you have studied about the potentiometer, where we had a path, where in the path we had some resistance coupled or wounded over a arm, and there we need to slide potential so that we generate the voltage. We slide the part so that we get the exact at a particular position. We know the resistance of the wire, and based on that resistance we find the EMF, the voltage generation. Fine. So almost same, the sensor works almost in the same way. So basically this potential sensor is used for calculating the angular position as well as the linear position. Fine. So how does it work? Let us just check in detail, like how it is constructed, what are the main things integrated, just a brief part. Fine. So we'll just look after that. So talking about a potentiometer, here what happens is that if there is a change in resistance, it will change. If there is change in length, like your potentiometer what you have conventionally seen, you change the you move the thing over the length of the resistance, the voltage changes. Fine. Here also same thing is happening. Once we change the connector over the resistance, the wire, the path, it will change something, some voltage generation will be there. So let us look after this. So here basically we have three terminals. You can see, I'll just make the diagram here. Fine. So talking about the rotary potentiometer, sensor. Fine. So talking about the sensor, what do we have here? So like suppose we have a resistance. Fine. This is the resistance, and we have three terminals in this resistance. So first of all we have A resistance, we have C resistance, and in between we have a movable part. So let's name it B. Fine. Now if suppose talking about this resistance, we have 100 ohm of resistance. Fine. And we have a knob here. This is the knob connected here. We have this knob. Once I move this knob, if I rotate this or move this, give a linear displacement or an angular displacement, the arrangement is such that it will change the position over the length between the point A and B. Fine. The total resistance is 100 ohm here. Fine. If I move this now, for example, if the resistance, if the pointer B is kept at the mid position, so the value of the resistance value from the point A to B, that is R A B, if it is at the mid position, it will be 50 ohm because it is kept at the mid position. Similarly RBC resistance will be 50 omega. Fine. If the pointer B is kept at 1/4 or quarter distance, at a quarter distance or 1/4 distance, that is 25% of this total 100 ohm, then the resistance of A and B, the point A and B, that is R A B, for 25% or 1/4 position, it will be 25 omega because the total is 100 omega. Similarly BC, R BC, for quarter position, it will be 75 omega. So the main motive of showing this one is that the position of this pointer determines the the position of this pointer, the pointer B, tells us the resistance value of a certain distance, the distance or the certain position, that is from point A to B what should be the resistance value, and from point B to C what will be the resistance value depends on the pointer position, the pointer B position. Fine. So, and one more thing, in this sensor we have the resistance is directly proportional to length of the resistance. So we can say that the change in the wire, the change in the resistance of the wire over its length will give us the voltage value, because the voltage will change. So this is the basic principle of the potential sensor. Talking about the diagram, that is, let me just show you. So if I show you properly, fine. So we have something like that, and shaft is connected here, fine, and from the shaft we have a pointer here, and here over the sensor you can see some markings are there, like here we have 0 degree, here we have 30 degree, 60 degree, here we have 90 degree, 120, 150 and 180 degrees, and a pointer is connected, and this pointer is connected to a shaft, and from here we have 3 terminals. Let's say this terminal is A terminal, this one is B terminal, and this one is C terminal. So, and here we have, I'll just show you with the dotted lines. Over here, over this pointer we have the knob. So in the sensor also you can see this is the knob I have, this is the knob I have, and here I have 3 different terminals, terminal A, terminal B and terminal C. And if I rotate this one, a shaft is connected to the pointer B, so as to change the position of the pointer B, so that I can place it at a particular location, and they have calibrated in such a way that I can see the angular the position, the angular marking I can see, that is 0 degree, 30 degree, 60 degree, 90 degree, 120 degree. So these are the angular markings we have here already. They have calibrated with this machine, and the main purpose of this experiment is to change the angular position. So this is a analog potential sensor, where the input we are giving in an analog value, that is 0 degree, 30 degree. In the analog values the input is given, and here in the software we can view actually how much is the actual values we are getting. So first of all we'll collect the data. Now talking about this experiment, what is the format of doing the experiment, how can we do the experiment, what is the basic idea? Fine. The basic idea is to find the angular position. Fine, that is okay. By changing the resistance over the length, the resistance is distributed over the length, and at particular position we have different values. Like for example, I told you, if the total resistance value is 100 ohms, and if we place the pointer at only quarter length or maybe 50%, fine, the resistance for a particular position from point A to B will show a different value. Then for 100 ohm it is showing 25 omega. Fine. So this is the basic idea. Once we get the resistance value, this sensor is calibrated in such a way that it will generate a voltage signal. Fine. How do we do the experiment? We have the sensor here, we have connected all the wires here. You can see we have a power cable. This is the power cable composer. So we have a power cable here, just so as to power the whiteboard, that is the add-on Elvis board. Fine. We have a data cable. That data cable we have connected with the system. This is the end of the data cable. Fine. A data cable is connected with this whiteboard, and the whiteboard is being powered, normal power. Fine. And the sensor is connected. So this is the sensor integration. I'll just switch it off. Fine. And I'll just show you. Okay. So this is the part, this is the connector we have here, and this connector goes here, right here. Fine. This is the connector, it goes here. So I'll just okay, fine. Okay, it is connected. I'll just switch it on. Fine. So once I switch it on, there are some LED bulbs, so that I can know that it is ready, or some problem, some connection issues are there or not. So we have the power on button and the ready button. Fine. The active button will only blink once I press the power on button. After that, for 1 or 2 seconds it will blink. After that it will go on. Fine. like it will be switched off, and the ready button and the power on button will be blinking. And we have some sensors also. This sensor, this LED bulbs are showing us the voltage value, the power it is getting. The board is getting how much voltage of power. So this much voltage of power it is getting. Maximum is 15 volts it is getting. Fine. And we have some encoder lights also blinking. So this is compulsory. Fine, that's okay. Now talking about the experiment, what do we do first? First of all, what we will do is that we will open the software part. I'll just show you, and then we will take the values. Fine. For example, I will just rotate the knob and then place the knob at 0 degrees, and corresponding to 0 degree it will show a value. Fine. Corresponding to 0 degree, it will show a value in digital form. It will show a value. So I'll just mark it. For 0 degree, I will mark that value. For 30 degree, I'll move to 30 degree and I'll mark the value. After 6, then I'll move to 60, 90, 120 and so on. I will move the knob, and corresponding to those values, I will get a particular values. Fine. That value is called measured value. Fine. This is the sensor value. Sensor value will be in analog format, something in degrees, that is 0, 30, 60, and corresponding to that I'll get a measured value in some numbers, 0.1 or 1.5, 2.5, 3.65. This type of corresponding values I will get, and based on that values I will get offset and gain. Now talking about the offset is the deviation from the actual value. Why we are doing all those things? Because this sensor is not calibrated. So that is the part where we get the datas. After getting the data, will the software value and the corresponding value, after I get these two values, it will automatically show me the offset value, how much is the deviation. Fine. Once I know the deviation, I will do the calibration and get the output data. In the calibration section, I will just check for whether if I place the knob at 0 position, whether it is showing 0. At 30 degree, whether it is showing 30 degree, at 40 degree, whether it is reading 40 degree. So the main purpose is to calibrate the sensor and get the data. Fine. Calibration will be done 30 degree, 60 degree, corresponding values will get corresponding values. With this corresponding value, we'll get the offset value. Offset is the deviation from the standard value. Once we know the deviation, it will automatically calculate all those things. We don't need to calculate the offset, how the offset is calculated or such, nothing such. These things are already done by the software. Once we get the offset value, we'll just make sure that at a particular location whether we are getting that value or not. That is the simple purpose of this experiment. Fine. So let's go for the experiment. So here is the this is the sensor package we have here. We have downloaded the sensor package for this board. Fine. The software which we are using is Labview 2018, and this is the package we have here. So this is the software. Fine. And here you can see we have QNet Mechatronics sensor. Fine. I'll just click it. Okay. Okay. So a window has been popped up. So you can see this is the Labview symbol. This is the yellow color one, the left side corner upright. So this is the Labview symbol we have here. This is the Labview layout, the software layout. Fine. And here we will find for the particular package, the particular VI. VI is the virtual instrument. VI is the part, the window where we can do the calculation part. We'll take the reading, we'll give the input data, take the output data. So all these things are done in a special window that is called virtual instrument. For each and every sensor, a particular virtual instrument is made. For example, for encoder we have this one, sensor encoder.vi. We have similarly for infrared, we have sensor infrared distance.vi. We have for magnetic field, for piezoelectric, for potentiometer, for pressure transducer and so on. So we will go for potentiometer VI. So VI is the virtual instrument. This is the virtual instrument page where we will take the input data, give the input data, take the output data. So in this part you can see it is written that uncalibrated output. Fine. And some the steps are also written here. For example, the first step is rotate the onboard potentiometer to a certain position, enter it in the pot angle. Pot angle is the angle which I am giving. for example 0 degree, 30 degree, 60 degree, what I am deciding, what I am the knob which I am rotating and placing the pointer at a particular location, that is the pot angle. Sensor output is the output which is showing, so the output which will show will get it from here. See, this is now 0.00, so this is the output result I will get. So I'll just rotate the knob, fine, and do the thing. And before that, in the manual it is given that something J10, J8, J1, J2 something. If you read the procedure correctly in the carefully in the manual, we have something in the procedure section, we have something select the device, correct device, that is J10, J1, something like that. So this is the device name. So first of all what we will do is that select the device. This is the device here, so we have selected the device, fine. Now we will just run this one. This is the run option, fine, run. Now it is running, and you can see since it is uncalibrated, it is something showing, it is the pointer is something at 1. This is the pot output voltage in voltage, and this is the time. So in the pot output voltage it is giving something 1 voltage, and the output result is 0.86, fine. So now it is uncalibrated, we are going to calibrate this one. So talking of the pot angle, I'll just rotate the thing. For example, let's say 30 degree. I've placed the angle at 30 degree, and the output voltage which I'm getting is that 1.30. So 1.3, fine. And then I'll move it to 60 degree. So I have 60 degree, and corresponding to 60 degree I have 1.84, fine. Now I will move it to 90 degree, fine, 90 degree, and corresponding to that I have 2.7. Similarly 120, so 120 degree, and here I have 3.26. Similarly 150 degrees, so 150 degrees, and corresponding to that I have 3.83, fine. And then 180 degrees, and corresponding to that I have 4.32, fine. So this is the thing I am getting, and in the right hand side, the sensor reading, you can see this is the pot angle which I have given, and pot output, the sensor output. So they are merging these two values, and they are getting us the data. So you can see we have two different lines, that is blue colored line and red colored line. So in the up you can see here blue colored is the measured one, what I have measured, and curved one is the standard curve fit, fine. So if you look very carefully, the red line is almost straight. The red line is almost straight, but if you see carefully the blue line, so you will find that 1 point I got here, 1 point here, 1 point here. So I have some kind of deviation in this line. You can see here again I have 1 point here, 1 point here, but talking about the red line, since it is the standard line, so it is almost straight, and it should be straight, fine, no problem. And below you can see one thing, that is I am getting slope value, that is 48.2 and minus 33.6, that is the offset in degrees, fine. So this is the offset and the slope I am getting. So I'll just stop it. So for stopping I'll just click here, stop button. It is stopped now, fine. I'll just remember this one, the slope is 48.2 and 33.6, fine. So in the sensor value what I can do is that I can, okay, and before that I'll just place the knob at 0 position, fine, fine, and I'll just run the thing, run the calibration sensor. I'll run the calibration sensor here, fine. Now it is running and it is at 0 position, fine. I'll just place this data. The slope was 48.2, and let's check it, 48.2 and 33.6, okay. and the offset is minus 33.6. Fine. So this is the thing I got here. Fine. And I'll just place the sensor in my board at a particular location so as to get the exact value in the calibrated output region. So this is the calibrated output region. So whatever value I'll put it in my sensor board, I should get the value same in this part, that is the calibrated output part. So this is the main objective of our experiment, to get to do the to make the sensor calibrated. After the calibration is done, we should get the exact output. What the input, the amount of input which we are giving, the output should be exactly same. Fine. So some values, let's see. Okay, so now it is at 60 degrees, and you can see some values is there, might be because I cannot match the thing properly. So it is showing 61 point something 3 or 2 maybe. Fine. So it is almost calibrated. Some error will be there because I can't move the knob exactly at the same position. Fine. Let's move it to 90 degree. So 90 degree. Okay, now it is at 90 degree, and you can see some values. So this error will get more and more once we go for the higher values. That is very obvious because we have some values, error values, and that is keeping the error value what we have initially, that will keep on adding if we go for further bigger values. Fine. So this is the main objective of our experiment. We can briefly do one more. Fine. Fine. So as to get the proper data. Fine. So I'll just close this one, don't save, open it again. Fine. Go here. Okay, select the device first of all, hit the done button, next step. After hitting, you will find some values, so make it 0. Now it is 0, at 0 position. Uncalibrated output is 0. The graph is at 0 position. Everything is set to 0. I'll enter the pot angle. Fine. Let's say the pot angle is now 15 degrees. So I'll move to 15 degree. Okay. Now it is at 15 degrees and the value is 0.98. One more value. Fine. One set of value, one new set of value we are taking. And then after 15, let's say I move to 30. It is very difficult to match the knob. Fine. So let's try. And I have 1.38. Fine. 45 degree. Okay, so 45 degree I have 1.70, 1.7. Now 60 degrees. Fine. So for 60 degree I have 1.99, 1.99. Fine. Okay, 75. For 75 I have 2.4 and 2.38, 2.338. Okay, and then 90. Here I get 2.7. Fine. Oh, and then one more value. Okay, and here I have 105 and then 3.12. Okay, fine. So you can see the graph is still better than the previous one. So this will occur because once you rotate the knob and place it to the particular position, so you might not get the exact location, the exact point. So now if you see the graph very carefully, it is almost merging with the red line. Previously the error margin was moved, but let's check for this one. Fine. So we get the slope here as 43 and minus 27.6. Fine, in degrees offset. So 43 and 27.6. Stop it. 27.6. Okay, so slope is 43, slope is 43 and offset is 27.6 minus 27.6. Fine, and we'll check the value. Fine. Okay, you can see now the best part is that, see, I have not changed the knob. The last value what I entered was 105. I have changed the plot angle from 15 to 30 degrees to 45 degrees, 60 degrees, 75 degrees, 90 degrees, and last value which I have rotated was 105 degrees. The best part is that if you go to calibrate sensor and put the offset value in the calibrated output region, you are getting 106.65 degrees. So it is automatically detecting the present location. So you can say that almost we have calibrated the thing. Fine. Okay, that is the best part of the thing. And here also we have the pointer. The pointer is located at 106 position. Let's move it to 120 degrees. Okay. Okay, so I have moved it to 120 degrees. You can see, just we can just have a look here. So it is at, okay, so you can see the pointer is at 102 degrees, and in the screen also you can see the calibrated output is 102.61 degrees. Fine, this is the calibrated output. Fine, just calibrated outputs. Fine, so just stop it. So this is the basic idea of the experiment, so as to demonstrate the thing. So we have successfully demonstrated the sensor which we are having. Basically here what we are doing is that we are calculating the angular position. We have something, we have the marking of angles here from 0 to 180 degree, and we are moving the knob and we are getting the exact values. So these are the analog values we are, as an input we are giving, and digitally we are getting the degrees, exact the degrees. So we have taken the data, mashed it, got the graph. From the graph we took the deviation, how much is the deviation and how much is the gain, and putting the deviation and the gain value in the calibrated section. We have calibrated the software, and after calibration automatically it is detecting. My last value was 105 degrees. I have not changed, and once I put the slope value and the offset value, automatically it is detecting 106 degrees. So there will be some deviations, there will be some slight mistake will be there because we are moving it manually. So some problems will be there, but we are getting somewhat near to the exact value, the measured value. Fine. So this is the end of the experiment. I will upload the video as well as the manual. In the manual everything is written there. Carefully go through the procedure written there. Some values will be some values are already given there, like 0 degree. At 0 degree what should be the value, at 90 degree what should be the value. So you can view this video, and as per the video what values I took, you can make the report as per that values. Fine. So I have already dictated the values which we were getting. For 0 degree, what is the corresponding value? For 90 degree, what is the corresponding values? So all those values are dictated in the video. It is told in the video. Write the values. You can take those values and write it in the thing in your lab report, and you can do the calculation, show all the things, write the result, like the conclusion, write the precaution, that is mandatory. Fine. So that's for today. Thank you.